For the Pearson's R, we're going to go statistical analysis, continuous variables, test for Pearson's correlation. Makes sense. Click on it. I'm going to choose the two variables. They are nose and hand. Yeah, nose and hand. Then I click OK. And it gives me this awesome graph, which I know I'm going to need later. If you're using Windows or Mac, you can right-click on it to save it. More on that later. I'm going to put it away for now. So here's the Pearson's R. And I need at least 2 decimal places for this to be correct. So it's going to be 0.72, or there's a little bit of wiggle room in that too, but less for obvious reasons. It's a smaller number. 0.72. And then I click Submit. And it has marked me as correct. That's great. Question 2. This is it's going to take the answers that I typed from the last. Now, if I typed in the wrong answers, then the wrong answers will appear here. But it's going to show whatever answers I gave for my previous questions. Now, the next question is to get a graph. Now, I saw the graph, so I'm going to say Browse. I'm going to go find the file. Actually, I need to save it first, so let's go save it. You can right-click, Save As, and any format you choose to save it as is acceptable. I've already done this, so I've got it accessible already. I'm going to put it away. Well, I'm going to leave it up because I need to look at it. Browse, go find your file, and I think I called it nose. Here we go, nose, hand, scatter, and upload. You can paste it into a Word document if that is your preference, whatever it takes to make you comfortable with your uploading of the file. Save it in any format. I can read them all and upload it. There it is. Next, we go to question 3. Question 3 asks me to state HO and H1. So now we've done our descriptive statistics and our graph. Now we're doing the inferential statistics, and that's what all of your results sections will always look like. Now, unfortunately, I haven't found a way for it to show the picture of your graph for this question, so just use your imagination. Now, select answer. So HO, I want to test whether the population correlation, whether there is a population correlation or not. Well, the population parameter for correlation is the Greek letter rho. I understand that it looks like a P. It's not a P. And HO is that rho equals 0. There is no correlation. H1 is that rho does not equal 0. There is a correlation. That's it. Click Submit. And there we go. So now I've gotten this far. Go to the next question. And it's going to report whatever I answered. Whether right or wrong, it will show up here. I'm not giving away the answers. So here I have this link to the decisions tree and a video showing you how to use the statistics decision tree. You probably have already done those things by now. And so maybe you know that the assumptions for correlation analysis are all individuals are always required to be independent. That's always a freebie for every one of these. For correlation, all variables must be normally distributed. For regression, only the outcome needs to be normally distributed. But we're doing correlation right now. There can be no extreme outliers or influential points. The relationship between the input and outcome must be linear. And the variance has to be similar for all levels of the input variable. Now we're going to check each of those assumptions. Do I meet them? So do I meet the assumption for both for normality in both x and y? Let's look at our graph. The marginal box plot shows me that it is reasonably symmetric for hand, but nose appears to be highly skewed. See how it's got a very scrunched up box plot with a ton of outliers on the other side. So there are a lot of outliers in hand, but it is symmetric, so that's probably acceptable. But nose is not acceptable. So I'm going to say hand is okay, but nose is not. Oh, wait a second. Did I say that backwards? Nose is the one that nose is the outcome variable. Right, so actually we need both of them to be normally distributed, but it's particularly bad if the outcome variable is not normal. Okay, hand is okay, it is symmetric. Okay, so and you just type whatever your opinion is on this, and I'll read it, and if it looks reasonable, I'll give you credit for it. Now look at the scatter plot shape. Does it look like there's a clearly nonlinear pattern, like a curve of some kind? It's really hard to see because of all the outliers, so I don't really know. But I don't see any obvious nonlinear shape here. It looks, I could believe that it's a line. Are there any outliers? Yes. Boom, boom, boom. There's a ton of outliers. There's also one down here. So yes, there are a lot of outliers. They're pretty close to the line, so I don't know if they're influential or not. Are there influential points? Well, actually this point down here is far from the line. That would be considered influential. These others, it's hard to tell because if I removed them, maybe the line would change dramatically. I don't know. Is the vertical spread approximately equal across all x values, or do I violate the assumption of equal variance? If the variance is not approximately equal, where is it wide? Well, the variance is really wide on the left side, and it gets very narrow on the right side. So that's what we see, at least with this data set from this quarter. Do we meet all of the assumptions? Not all of them. It looks like we violated homogeneity of variance, we violated influence, we violated outliers, and I think the only one we met was linearity. It seems reasonably linear. Other than that, we violated all the assumptions. So you just say whatever you want to say. I'll read it, and as long as it's thoughtful and reasonable, as long as it's accurate, makes sense, I'll score you for full credit on that. Yes, I'm going to submit it and continue. Next. So that's the assumption check. And we're going to move ahead on, even though we violated the assumptions, because this is a class exercise and not a real data set. A real data set, if you saw something like this, you would be suspicious, you would need to do something to fix it, and you would not, it would be unwise for you to move on, because the assumptions on which the math is based are not satisfied. So that means that this test that we're about to do is not actually tenable. It's not actually valid. It doesn't give us meaningful information. We're going to move on and just interpret it as if we did meet the assumptions. So get the 95% confidence interval for the correlation and get the t test. So that output is already here. Here's the 95% CI. It's 0.55 to 0.83. And you want to use at least 2 decimal places here, because otherwise it's just not reasonably close. The t, 7.053. 7.053. Degrees of freedom, it says 47. And the p-value is very small, and I don't feel like typing it. So I'm going to copy it. I'm going to paste it. That's going to be great. So submit. I got all green boxes on that. I'm ready to move on. Last question for the results section. So this is what a results section looks like. Descriptive stats, graph. Inferential stats, which consists of HO, H1, and alpha. Your assumption check. It says I haven't answered question 4, but I have answered it. Oh no, I didn't. I didn't answer it. It's true. Whatever I had typed there, it would be writing that right now. So then the confidence interval and hypothesis test. Then a decision about whether or not to reject HO, and an interpretation of what this means in plain English. So this p-value is very low, so I will reject HO. Interpretation is not complicated. If I look at the slope, look at the correlation, I see that it is positive. Where'd the correlation go? R is positive 0.72, so that means it's a positive relationship. The p-value is very small, so it's statistically significant. So I reject HO. That means that I conclude that people with larger hand spans have longer noses. That's it. That's what it means. That's what we discovered. We discovered that, and then we're not just talking about in the sample. I should say people in the population. People in the population. So we're not talking about the sample. We're not talking about the people we observed. I'm saying in the population beyond this sample. So you notice I says your answer must include the words nose, hand, and population, right? People who have longer hand spans have longer noses. And that's it. Don't try to make it any fancier than that. Okay, I'll make another video showing you how to do the regression part next. Look forward to it.